Hello everyone, and welcome to this fourth video in the series of videos on AI. The first one was the AI 101. Then we saw the hottest topic uh, in AI, the generative AI. The third one, we saw how to build applications with generative AI. Now, this is the latest topic within generative AI, which is the AI agents. Okay, so let's dive in. Okay, so this is like a typical like a workflow of AI agent today, right? So maybe like there is a user, right? So that's kind of where it starts, right? So the user talks to the agent, right? This is the AI agent, right? Now AI agent gathers data. It could be from a feature store, could be like a metadata store, right? Maybe it gathers some more information like from email or whatever document store and all it may have, right? On An interesting interaction it has is also with the LLM, right? Which kind of all that is involved in a AI agent workflow, right? So which kind of makes it interesting and intelligent. Okay, so let's kind of just put it together. Like, what are AI agents? Okay, so first of all, they are goal driven. Now, this goal is set by the human, right? The human could be like a CEO of organization, could be a programmer, right? But it's important that it's goal driven and it's set by a human. Okay, I mean that is an important part here. As we saw, it is interactive, right? So now there are two types of interactions involved here, right? It interacts with the environment, like it interacts with the user, for example, to collect maybe it asks questions to the users to gather the context, right? Other thing, it kind of interacted with the environment to collect necessary data, right? Maybe from that feature store, from the email, right? So on and so forth, right? On the other side, it interacted with the LLM. Okay, now what did it do interacting with the LLM? So it tried to understand the question, right? What is required for this question asked by, or whatever answer provided by the user that was posed by the agent, right? Or vice versa. Or maybe to answer the question that the user posed. Okay. Secondly, it had to reason, right? I mean, it understood that what to do, and then it reasoned why to do that, what steps to take, right? So this interaction is important. That basically gives the AI agent the intelligence, right, or the cutting edge over traditional program. Okay. The next thing is the decision making, right? Now this AI agent is intelligent, right? So I mean, it got the context, right? It's completely data driven, right? It did the reasoning, it understood that question, right? The decision that it makes is informed, right? It's based on the context of the data it collected from the environment, right? And it's rational because it kind of did the reasoning through the LLM, right? And the last thing is it's autonomous, right? So not only it kind of made an informed decision, but it actually acted upon it, right? It took an action and it was intelligent, right? Because it was informed, it was rational, right? So that is a very important aspect of these AI agents, that they are autonomous and they take intelligent actions, right? So it's like an actionable insight that is kind of brought forth by these AI agents. Okay, so what are the benefits? So the first thing is the improved productivity, right? So all the repetitive tasks you can delegate to AI agents, right? And only when the AI agents cannot make a decision, or kind of its confidence is low in the actions, right? It will prompt the user for the intervention. So a lot of the, like 90% of the activities would happen seamlessly, automated way by the AI agents. So because it's not only taking decision, but it's actually taking intelligent actions, right? So that way the user can focus on business, right? A lot of the stuff will be taken care by automatically by the AI agents, and only 10% things it will prompt the user. So that kind of relieves the user of a lot of repetitive tasks. Okay. It reduces the cost, right? So now, as you can see, right, manual processes have more cost, right? Or they can be error prone, right? So a lot of that cost will be eliminated. I mean, it brings in automation, right? I mean, as we know, automation reduces cost, right? So uh, there is a reduced cost in processing because of AI agents, right? The predictions are data driven, right? So because it has access to all the information that the enterprise has, like the feature store or the document store or the emails of the user, right? So whatever it kind of predicts is data driven completely. Okay, it's not like out of thin air. Okay, it improves the customer experience, right? So first thing is customization, right? Because when a user asks the question, right, the agent will look up the user's emails, right, or the user's document. It knows who's asking the question, right? So it can customize the answer, right? Because the answer might be different if the CEO asks the question or CTO asks the question, right? So it can provide that customization, right? And the second part of this improved customer experience is it's conversational, right? It's interactive, right? Because when the user asks question, right, maybe the AI agent will give an answer and say, oh, okay, this is what you think you want. Do you want something more, or is this sufficient, right? So on and so forth, right? And because of the sort of interesting language nature, it can keep the conversation engaged, right, improving the customer experience. And it enables use cases, right? Something that was not possible before, right? So we kind of saw that earlier also, like the whole benefit of generative AI, that it's generating the new content, right? So it makes it exciting, right? I mean, that is one, and it provides a natural language interface, right? Which we saw in a couple of use cases and the case studies that we did, right? So, I mean, you don't have to remember all the complex APIs or specific calls of a specific platform, right? Or even uh, the different calls you need to make for different applications, right? You whatever comes naturally to you, ask like, what is get my IP, right? That's what we saw in sort of one of the examples, rather than saying if config dot curl if config dot me, right? It's a natural language interface. I mean, uh, give me weather of Pune, right? And then you don't have to know what is the web service, or what is the web service you have to go to, right? What is the API call you need to make, what parameters to pass, right? You just say, uh, what is Pune's weather, right? And this AI agent will take care of that. Okay. Uh, Challenges, right? I mean, having said all this, I mean, what are the challenges with doing this? What are the challenges with AI agents? So now, as you can see, right, the AI agent is dealing with massive amount of data, right? So now data privacy is very important, right? I mean, all the document stores, feature stores, right? The emails, right? I mean, it has to be very secure, right? It has to take care of all that. Okay. Second thing is ethics, right? I mean, as we saw that, I mean, some of these models could be biased, right? Or unfair, right? Or toxic, right? Or we also discuss at length the problem of hallucination, right? So all that is a challenge, right? Because when it comes to ethics, you want to take care of all these aspects. Okay. Uh, so now AI agents is still relatively new technology. So obviously there is some knowledge involved, right? I mean, as we are uh, going through these videos, you are also learning, right? But then there is some learning curve before you actually get to doing stuff, right? So there is some knowledge involved and some experience, right? I mean, obviously you have to try out these things, right? You'll learn from your experience, right? So that's why there is some technical complexity involved here, right? And as we saw, right, I mean, there are resources that are required to train the model, right? Or even fine tune. If fine tuning is much cheaper than training, it's still some resources, right? I mean, even to sort of, host a model to do inferencing, it's not cheap, right? Depending on, I mean, even we saw Olama, right? But Olama also, right, like a 7 billion model you can run, but probably 16 billion you cannot, right, on your laptop, because laptop would have typically 16 GB of RAM, right? So there are some resource requirements, right, that you are talking about here, right, which are still a challenge. Okay. So in these AI agents, what are different design patterns? So the first one is reflection, right? So where you examine the work to improve, right? I mean, you kind of, do the work and then you examine the work to improve further on that work. Right? It's like a little iterative. Tool use, right? So as we saw, that these sort of, there is a knowledge cutoff, right? So then if you want to ask an LLM that, hey, what happened yesterday, right? Then you could say that, hey, you can do a web search, right? So the LLM can do that, right? So you can do a web search, right? You can execute some code, right? Because what may happen is if it's like, some complex function, right? Or like maybe an integral of some equation, a derivative of some equation, right? So LLM need not get it right, right? So you provide that function and you say, hey, execute this, right? Or like, even this function of a web service call, like getting a weather, right? So LLM doesn't know about weather, but it knows where to go to make that call, right? And then you need to tell it, right? What are the parameters, right? It extracts the city name like Pune, right? And passes it to that service, right? And then obviously gets the results, and it knows how to parse those results and how to pass it back. It may nicely package it. Oh, it's very pleasant in Pune, or it's very sunny, right? It's very hot. I mean, that kind of packaging it can do to make it interesting to the end user. Okay, the next one is planning, right? So sometimes if the LLM kind of thinks through, right? I mean, say for example, if it's a matter of writing a PhD thesis, right? So I mean, there are lots of steps involved, right? I mean, you come up with an outline, you do the research, right? For each sort of task, you kind of do some specific things, right? And then you so execute on that step, right? Of each of the steps of that plan, right? The next one is RAG. It's retrieval augmented generation, right? So what you do here is you augment the intelligence or general intelligence of your LLM with specific intelligence uh, that is in the proprietary data of your organization. I mean, that's what it is. Okay. uh, and the most important today, which is again the hottest topic within the AI agents, is the multi-agents, right? So here more agents are working together, right? And they are basically doing divide and conquer. Okay, so let's dive into each of these patterns a little bit. Okay, so reflection, right? So here, I mean, this is from Andrew's course, right? So basically, you can see, right, there is a coder agent, right? So Andrew says, please write code for doing something. Okay, now this coder gives the code, right? So then the user finds that, oh, like from the inspection he figures out there is some bug on line 5, and he probably also has an idea how to fix it, right? So okay, there is a bug on line 5, fix it by blah blah, right? So then this critic agent, right? So now it could be the same LLM or it could be a different LLM, right? So it actually does that and gives the modified code, right? So then like maybe the programmer actually runs unit test and it says, okay, test 3 is failing, so it tells the critique, oh, unit test 3 failed, right? Now it improves it, right? So I mean, as you can see, it's kind of uh, critique of the work that is done, right? And it's iterative, right? And then obviously from the first to the third, it will be much improved code, right? So that's what this reflection is all about, right? Reflect on your own code or whatever, on your own work or behavior, right? So that is the first pattern, reflection, right? The next one is the external tools, right? I mean, we already saw this search, right? I mean, for the knowledge cutoff, for example, right, of the code execution, right? We saw that some complex functions like uh, well, whatever, right? Integral or differential, right? Or get me a weather, right? A simple tool for a web service call, which then passes in the city name provided by the user. Okay, this is the second pattern, right? The third one is plan the steps before acting, right? Planning, right? So this is talking about a problem from a computer vision, right? So the computer vision problem is, oh, you are given an image, right, of a boy, and give me a similar image of a girl, right? So then computer vision says, okay, similar means what? Like, you detect a pose of that person, right? So it says, okay, determine the pose, right? So then the pose says, oh, okay, maybe the head is slightly slanted to the left, right? The arms are like, bent in elbows, right? Things like that, right? And the next one it says, okay, in this pose, draw a picture or image of a girl, and it comes up with this. Okay, so this is from this Hugging GPT. Okay. Uh, okay. So the next one is RAG, right? So let's spend a little bit more time here because it's important, it's interesting, right? So let's say you are given a question, is there parking for employees, right? So now obviously this is not a LLM, generic LLM question to answer. It has to be answered by that particular company, that particular organization, right? So now you provide that kind of proprietary intelligence, right, which is from the company documents, right? So now documents could be of different types, right? Benefits, leave policy, facilities, payroll, right? Now from this question, right, parking, so it figures out, oh, this is a facilities question, right? So now that is done by LLM, right? But then actual context, right, it retrieves from that document, right, which is okay. So it says, okay, parking policy, all employees may park on levels 1 and 2 of the office slot, use the entrance on front, blah blah blah. Okay, so now basically what LLM does is it kind of or maybe your application, you can say what it does is, or the agent, I mean, which is what we are talking about here, right? So the AI agent basically looks at this question, it makes a call to LLM, right? So the LLM kind of gives the intelligence that, oh, like you need to look up the facilities document, right? Now all this information is local, this doesn't go to the cloud, right? And like whatever it retrieves also kind of uh, sort of with you. Okay, now it kind of uh, extends or augments the context uh, that is given to the LLM, right, with this information. Okay, and then now what LLM can do is from this information, it can give a better or very intelligent answer, right? Say again, first of all, it says parking, yes, it is available, but it can give more useful information like it is on levels 1 and 2 and how to get there. Okay, so that is what RAG is all about. Okay, so so just to summarize, uh, basically the knowledge from the proprietary data is augmented uh, with the reasoning which is done by LLM. Okay, the context is gathered from the proprietary data and it's provided to the LLM as additional context. Okay, maybe in a prompt or whatever, right? So you can design a prompt template like that. Okay, now there are specialized LangChain document loaders to work with different types of documents, and they typically use a technology called vector store. Okay, so if you go to the LangChain document loader page, you'll see a lot of them. There are probably 30-40 of them, right? But the most important ones are CSV, text, PDF, Microsoft Office. Okay, so actually one of the examples that we saw about that sort of that case study that we saw for authentication log questions getting answered. So we actually use CSV agent there. Okay, just to kind of give you a glimpse of what CSV agent is capable of. Okay, now beyond these document loaders, there are specialized agents. I mean, they are themselves called agents. Okay, because they are more intelligent, like SQL agent, right? That works with databases, right? And you might have heard about this sort of some offerings like text to SQL. So text to SQL actually uses this SQL agent on databases. Okay, now there are even more specialized capabilities, right, which kind of combine this unstructured, which is coming from these document loaders, and structured, right, coming from SQL agent, called Llama Index. Okay, now again, kind of going back a little bit, I mean, earlier I had said that uh, GenAI doesn't work very well with structured data, right? But now, as you can see, there are agents which sort of address that, like SQL agent, right? I mean, it's a structured data, right? And there are capabilities like Llama Index, right? They work on unstructured as well as structured, right? They can combine it together. Okay, so some of this code you can see in my GitHub, in this GenAI repo, right? Most of it is in LangChain, right? So you can take a look, you can play with it. Okay, so that was a fourth design pattern of RAG. Okay, now the last but not the least, right, which, as I have been saying, right, it's the multi-agent uh, of the multi-agent pattern. Okay, so I mean, it's a breakdown of jobs into tasks, right? It's a divide and conquer, right? So it's a typical, like, a software organization, right? Where, like, you basically have sort of a waterfall model traditionally, right? Where like, the CEO, CTO, and the CPO come together, right? They discuss what needs to be done based on the customer requirements, right? And then they pass it down some specification to the coding team, right? Now this coding team sort of, takes that specification, right? Now CTO might be involved here, right? For a small company, he could actually even be coding, right? uh, the designer might have to be involved to kind of make sure that whatever code is happening is for the right requirement, right? And obviously there are programmers here, right? Then they generate the code, they pass it to the tester, right? So tester could be, again, a lot of automation testing happens today, right? So programmer, right? It could be a reviewer of the results, right? A manual tester also in some cases, right? They just kind of, execute some commands and verify the code is working fine, right? Then this well-tested code is passed on to the documenters, right? They come up with the documentation, right? That gets reviewed and ultimately goes out as a manual, right? Now, uh, this basically can be done by a multi-AI agent, right? So as you can see, they'll be given the roles, right? I mean, the roles like CEO, CTO, CPO, right? They'll be told what exactly to do, right? Programmers, designers, right? Reviewer, right? Right, maybe you can have even a technical documentation person here, right? Different roles, right? And they work together to kind of, do the divide and conquer. Okay. uh so here are some references for uh this particular video. So again, if you like the video, click the like button, subscribe to my channel, and the next video will be on the multi-AI agents, the frameworks for multi-AI agents, and we'll look at some samples as well there. Okay. Okay. Thanks.